So we are going to finish 4.8. So we did almost all of 4.8 last time. I did skip number 3. I don't want to do number 3, but we are going to come back and do number 4. Everything except for the last problem we did was all just a word problem. We drew a triangle. We labeled the sides. It was a pretty easy either sine or cosine or tangent, and then we were able to solve. The last problem though that we did, and this is like the one that we're going to do today, which is kind of why I left it for the end last time. We had to draw essentially 2 right triangles in one space. So if you remember, we were talking about this situation where we had a man standing at the top of the building up here, and he was looking down at a car. And while he was watching, the car started somewhere and then it moved closer to the building. And the man noticed his angle of depression from both of those situations. So the first time his angle of depression was like 22 degrees, and then the car moved closer and his angle of depression was 46 degrees. And so we wanted to know how far the car traveled. Now, as I have this lines traced, you know that's not a right triangle. So we had to essentially draw 2 smaller right triangles in order to help us figure out what that distance was. We drew a smaller pink one, and we were able to do tangent there. We said, okay, we know that the angle is 46. So we're doing tan 46 of 100 divided by x. And I did that right over here. Tan 46 of 100, my opposite, divided by a, x. And we got a number there. Now, the very second part, you guys kind of were like, well, could we do this a different way? And the short answer is yes. I thought it made way more sense to do it where my new long distance, if I took the entire triangle, it's not just the 96.57, it's the entire distance now, which is the small distance that the car traveled plus my 96.57. I feel like in class, we were wondering, could we just use a different variable? Like, could we just call this y? Sure. But then at the very end, then you need to minus off 96.57 from your y in order to solve. So either way works. The reason I did put a variable in this is the one that we're going to do. We're going to have to kind of play with letting a variable sit in there uncomfortably for a little bit longer than we're used to. So I wanted to kind of get us used to that. So I had tan of 22 equals 100 over d plus 96.57. And then we started simplifying from there. We ended up finding distance was 150.94. And then we were done from that point. Does anyone have any questions reviewing that problem we did last class? Okay, the next problem is super similar. So we're going to start from there. I've got to go back up to number 4. It's saying this large helium-filled penguin is moored at the beginning of a parade route awaiting the start of the parade. We've got 2 cables attached to the underside of the penguin, and it makes angles of 48 and 40 to the ground, and they're in the same plane as the perpendicular line from the penguin to the ground. Lots of details that truly don't matter. It says if the cables are attached to the ground 10 feet from each other, how high above the ground is the penguin? So let's draw a picture. It's going to look a lot like the picture we drew on the last problem. I'm going to draw a big right triangle. This is my penguin at the top. If I was more skilled and could draw a penguin, my penguin would be at the top of that triangle. And one of my cables, this hypotenuse line right here, that cable is at a 48-degree angle, bless you, from the perpendicular. The perpendicular is not a cable. It's in the same plane as the angles. So I can think of the perpendicular as being an important line, which is helpful to us because we're in trig. We're only talking about right triangles. We need a right angle somewhere. Now there's another cable also attached to this penguin right here in the middle, and that's at a 40-degree angle. So I essentially have this little, this big yellow triangle that goes from the ground is a 48-degree angle and has a 90 degrees. And then I have a smaller, this green triangle, which has a 40-degree angle. Still the perpendicular, still attached to the penguin. Oops. The only other thing I think I know is that the cables are 10 feet from each other. The cables are 10 feet from each other, which is this distance right here. The point at which my angle is 48 to the point at which my angle is 40, that is 10 feet. We want to know how high above the ground the penguin is, okay? We want to know how high above the ground the penguin is. So I'm going to use an H to represent that. I'm also going to argue that we need to put a variable between 40 and the perpendicular because we're going to need to at least have a place filler there. I'm going to put X there. You can label your variables however you want. Okay, just like before, we're going to do a tangent for both the green triangle and the yellow triangle. Like I said, though, we're going to have a few more variables. You see, I have 2 variables here, and we're not going to get rid of one of them as fast as we would like. So I'll do the green one first. So this one is a 40-degree angle. And if we remember from the 40-degree angle, it's still a height, a vertical distance of H. But the green thing that I see is only a horizontal distance of X. Okay, so that was my green triangle. Can you write a tangent equation for that? We can write one, but we can't solve it. So let's write it. So I've got tan of 40, good, equals, perfect. Tan of 40 equals H over X. Can't really do much with this now. Let's just leave it. We'll come back to it. We're going to do a similar thing with that big yellow triangle too. So I'm going to redraw my yellow triangle over here, kind of emphasize it's a little bit bigger. Still a 90-degree. My angle is 48. My height is still H. But what's my horizontal distance now? 10 plus X or X plus 10. Yeah, so I can't just do 10. I can't just do X. I have to do all of it together. 10 plus X. Or if it makes it easier in your brain, you can write X plus 10. And that's my yellow triangle. Same thing. I can't necessarily solve this yet, but can we write a tan equation with this? Sure. Tan of 48 equals what over what? H. H over. Raven's got it. H over X plus 10. H over X plus 10. Rocco. Yes, we use tangent because I have the sides that are given to me are opposite and adjacent. And I do not care at all about the hypotenuse.
Well, yeah, I know.
Like, why are we talking about like the height versus the hypotenuse kind of thing?
Well, I remember you said like most of the time we're going to use tangent, but I just didn't know like what determined.
Great question. Yeah, great question. The reason I knew is from the problem. It says how high above the ground is the penguin. So I wrote H here for my height. And then it tells me about my cables on the ground. It says the cables are 10 feet on the ground from each other. So that means I'm now dealing kind of with these horizontal distance, and I don't care at all about how long the cable is. That's a good question. Okay. All right. Now we are going to simplify, and we're going to do some substitution. So I've got 2 equations, one with H, one with X, or both of them have H and X in them. If I solve for one of my variables, I can then substitute or plug that into my next one. So let's look at the first one. This one only has H's and X's. The first logical step would be to do what? Multiply by X on both sides. So I've got X tan 40 equals H. Now that I have H all by itself, I have X tan 40 equals H. I can come over here and plug X tan 40 in for my H. Is everyone okay with that? Yeah, wow is right. So I've got tan 48 equals X times tan 40 over X plus 10. Okay, At this point, if you want to put tan 48 in your calculator and get a decimal and kind of carry that through, and put tan 40 in your calculator, carry a decimal through, go for it. I'm probably going to wait till the very end to try and plug it in, or I'm going to wait a little bit longer to plug it in. But if at any point you want to do a decimal so it makes more sense, you can do that. Yeah, Drew. Great question. They can't, because there's a plus in the denominator. As much as easy as that would be, there's a plus in the denominator. So don't get tempted. Don't do that. So over here, I'm going to do kind of the exact same thing I did on the other side. I'm going to get rid of the denominator. Let's multiply by x plus 10 on both sides. And I am going to distribute on the left side. So I am going to do tan 48 times x and 10 times tan 48. So I've got x tan 48 plus 10 tan 48. Distributing. And on the right side, I got rid of my denominator, so I just have x over, or x times tan 40. Again, if you decided to go put this in as decimals, then none of this would really matter, because you would be able to just kind of use your numbers and see what works. But like, I can't do anything with an x tan 48 and an x tan 40 right now. So if I get those to the same side, I can factor out an x and then I can solve. So if I minus off my x tan 48 from both sides, another thing we might be tempted to do is be like, oh, x tan 40 minus x tan 48. Can't the tans combine and it be like -8 instead? Don't do that. The trig does not work as necessarily as algebra would work. So don't just think you can add, subtract like that. When I move my x over, I've got 10 tan 48 equals x tan 40 minus x tan 48. So I minus my x tan 48 from both sides. As you notice on the right side now, I've got an x in both of those. And so I'm going to take an x out of that. So I've got 10 tan 48 equals x times tan 40 minus tan 48. I'm just going to do one more step and then I'm going to plug it in my calculator. So all I did was I took out my x from my x times tan of 48 and my x times tan of 40. So I just have tan 40 minus tan 48. How can I get x all by itself? Divide. Divide that ugly tan 40 minus tan 48. And so x equals whatever 10 times tan of 48 divided by tan 40 minus tan 48 is. Now, I think that's best math to kind of carry it all the way through and then just put it in my calculator one time. As I said, though, at the beginning, if you got here and you wanted to do, okay, I can put tan 48 in my calculator and get a decimal, and do tan 40 in my calculator and get a decimal, you can do that. You can just do algebra with decimals. I just think it's best math to show you this. So I'm going to go get my calculator up and I'm going to do that. We know I have trust issues with calculators, so I'm probably going to do tan 40 minus tan 48 first. Oh, and I still have trust issues, so I'm going to make sure I'm in degrees. If you're not in degrees, make sure you're in degrees. And so my denominator is going to be this negative 0.2715 number. And now I'm going to do my top 10 tan 48. And then I can divide that by negative 0.2715128837. Or you can round that, it does not matter. Well, why did I get a negative number? Did we carry something through? Oh, I mislabeled my angles at the very beginning. It's really awkward. Team timeout. Go back. No.
I was
Just
wondering-
switch
I-
them.
Did you wonder that,
I
Rocco?
was just like, well, that angle is bigger. I was like, why? I was like, okay. I'll just do it.
Oh no. Trust your gut, Rocco. You had it.
Better
call, Rob.
It's all no. It's all my fault.
Nah, it's
What the heck, Rocco?
Come on, Rocco. Oh, I'm so sorry. Okay, yes, those angles should have been different. So go back and change all of your angles 40 to be 48 and make all your angle 48s 40. All right, let's make that 48, 48. This one's 48. This one should have been 40. The cool thing though, you're probably like, this is not cool, Miss White. Why are you acting like it is? The cool thing though is we messed up and I knew that I messed up. Do you see how obvious it was that we were wrong? Okay, let's think about why we shouldn't just go with it. Would I have a negative distance away from the like cables? So since we're dealing in distance, there's no reason we should have a negative distance. I'm just changing all of my 40s to 48s and I'm changing all of my 48s to 40. Those of you on the video, I apologize. Apologizing to the future.
I did not know you were recording.
Oh yeah, I've been recording. I apologize to G and A who's gonna watch this later. They're gonna be so mad.
You're like, oh, I finally get it.
Yikes. Okay, let me make sure this is right. Okay. This is what I'm gonna put in the calculator now. 10 tan 40 divided by tan 48 minus tan 40. Okay. You could have only changed the last one. I just feel like I had to change all of them. It truly doesn't matter. And I should have been more careful when I looked at it. So I apologize to everyone. Everyone in person and virtual. All right, so I get positive 30.9, and that answer makes way more sense. So 30.9 feet. All right, so if you were mad at me that I messed up the angles, you're gonna be mad because I'm not done yet.
What?
What variable do I actually care about? The height. I need my height. I know X is 30.9. Where do you want to plug it back in? I want to plug it in to this equation. I think that one's the easiest one to do. Yes, so I'm going to go 30.9 tan 48 equals H, and I'm just going to throw that in my calculator. So even though we had an extra step, it really wasn't that hard of an extra step. So my height is 34.3 feet. That's my height. And that's the actual answer. All right. What I should have known is that the smaller angle is farther away. The closer you get to a building, it's a bigger angle. As Rocco noticed, was this angle looks smaller than this angle, so it should have been labeled differently. So just so you don't make the same mistake I did, the farther away is the smaller angle, the closer we get is the bigger angle. All right, now we are done with 4.8. Woohoo! Anybody have any questions? Okay. We're gonna get into 4.7. I feel like I'm on borrowed time because I feel like as soon as I get like right in the middle of something, you guys are all gonna have to leave. But again, I'll stop the video. Are you guys waiting? You're like, please make the announcement, please make the announcement, please make the announcement. They said about halfway through, so I'm guessing you have about 9 more minutes. You will need your unit circle for this. When we take the next test, which is going to be on Tuesday, the 22nd, you will not get your unit circle. No, Monday's a different test. The next test. The next test, yeah. So I keep talking about 2 tests because it's just been such a messed up kind of couple weeks. Yeah, Raven. President's Day. It's virtual, it's for Shamrockshire. No, you do have virtual. I don't know if I have your class that day or not.
Oh, that's why.
I think that's day 5, day 1, day 2. Oh no, I think I do have your class that day. And I got retreaters, yeah.
But we're not really missing that.
You guys, alpha retreaters, you guys are super lucky because you're only missing a review class period. Alpha retreaters, if you do not want to test on Tuesday, you can test later that week, but I need you tested by Friday, before we're virtual. Does that seem fair?
Yes.
Are Raven and Chris my only retreaters? Okay, I thought I had a handful more in this class. So my blanket statement to all the alpha retreaters, you may take it later in the week, but it has to be done by the end of the day on Thursday. Yes. Or you can do your quiz during class and your test during resource. I think that's smarter, but you can do what you want. All right. Any other blanket questions? Okay, when we get into this, I want to, I'm trying to think of like time-wise, what's most efficient. Let's actually do this. Let's talk about how do I need to learn the unit circle. You do not need one for this Monday. You do not get one, but the next test you will need to know it. What I'm thinking about doing is giving you kind of like a mostly blank unit circle, but with a couple things filled in, and then you can fill in the rest of it. So let's talk about how do I go about learning it? Yeah, Drew. You'll have to like kind of make your own unit circle, and then you can use that on the test. Yes. So let's talk about how we can like kind of memorize it. Maybe if you want to use a different paper, if you want to just do it kind of like in like the margin right here, I don't really care. I think the unit circle, if you know the first quadrant, then you know the unit circle because everything is kind of in reference to the first quadrant. We've kind of gotten to a place that I feel like you guys should be pretty comfortable with the quadrant angles, right? We know like 0 degrees has the point 1, 0, right? You guys are okay with that. We know 90 degrees is up here with 0, 1. If you don't, that might just take a little bit of memorization. You can think the same for 180 and for 270. What I'm going to say though is that in quadrant 1, and that's kind of how we built our unit circle, was we started in quadrant 1 and then we did kind of reference angles all the way around. We have to know 45, we have to know 30, and we have to know 60. In all the other quadrants, there's a reference angle that comes from 45. There's a reference angle that comes from 30. There's a reference angle that comes from 60. Does anyone remember off the top of their head what the XY of 45 is? Good. See, I promise that it would start sticking in your head, right? We've done it enough times that we kind of remember that root 2 over 2 is your 45-degree angle. From here, we can do 180 minus 45 to figure out what that angle is in the second quadrant. We can do 180 plus 45 to find it in the third quadrant. And we can do 360 minus 45 to find it in the fourth quadrant. All of those points have root 2 over 2, root 2 over 2. The only thing that's different is just knowing the signs. And do you remember what the signs are in like quadrant 2? Like, is X positive or is X negative in quadrant 2? Good. And what about Y? Positive. What about in the third quadrant? What are X and Y? What about in quadrant 4? Positive, negative. So I would argue you already know half the unit circle because you should know all the quadrant angles and you just showed me that you know the 45. What'd you say? Woohoo, you guys are doing great. The hardest ones are the 30 and the 60. If you remember what order the points go in, then you're gonna be good. If you don't and mess up, you will be bad, but I can't sugarcoat that, sorry guys. But what I will do is I will grade your unit circle, and then everything you do from that, I will grade based on your unit circle. So if you have the wrong point for 30, but you use that point like 7 times during the test, I'm not gonna mark you off 7 times during the test. I'm gonna be like, okay, you had what the real point should be, I believe it's √3/2, 1/2. If you have that flipped at 30, if you have 1/2 first, but you use that then throughout the entire rest of your test, then I'll just be like, all right, cool. That's like their new whatever. I'll mark you off the first time and I'll carry it through. So you might see a lot more of those CT points. Remember on tests, if you see CT, that means you did something wrong, but I'm not going to keep counting off points. Like if you did it wrong in the first step, obviously the next step's going to be wrong. But if your math is right, I'm not going to count you off double. So we know like 30 is √3/2, 1/2. And that's, again, you could do that all the way around in the circle. And then the last one is 60. And that's just the flip of 30. Flip every time. Well, just 60 always has 1/2 as its X and √3/2 as its Y. Where 30 always has the opposite. Yes. Let's do a quick hint on the radians. I think we know the 45, right? What would 45 be? Pi over, not 2. 2 is the axis. 4. We did not know 45. Okay. I remember 45 and 4 because they both have 4. Oh, yeah. Okay. I thought this was for granted, but remember that every like axis is a pi over 2. So like 90 is pi over 2, then we get to pi at 180. Theo, be nice to your friend. Then I go from pi to 3 pi over 2, and then I come back up to 2 pi. The 30 and the 60, I always mess up in my head, but I try to remember it's not what I want it to be. I want the 30 to go with the pi over 3, and that's not it. The 30 goes with the pi over 6, and the 60 goes with the pi over 3. The 30 goes with the pi over 6, the 60 goes with the pi over 3. We can talk more about this, trying to kind of memorize this. But I'm just kind of giving you a heads up as soon as possible that like you should start kind of thinking about those tips and tricks, because I'll give you some pieces, but I'm not going to give you everything. So you're going to be able to have to like do some of this on your own. All right. I knew that would happen at some point. So take everything. Don't come back. Just kidding. Don't come back today. Don't come back today. Have an awesome time. I'm going to stop the video. This is